Hello, everyone. In our previous lessons, we learned that the programming of industrial robots revolves around position points. These position points are based on a robot's 0 point. If the 0 point is lost for some reason, the robot will no longer function properly. In this lesson, I will explain the methods and steps to handle 0 point loss in robots. This lesson will focus on two main parts. Situations that require 0 point calibration. 1. When replacing robot components such as motors, reducers, cables, or pulse encoders. 2. When the robot's backup batteries are depleted and not replaced in time. 3. When the robot collides violently with the workpiece or the environment. 4. When the robot joints are moved manually without using the controller. 5. Other situations that may cause 0 point loss. What fault symptoms will appear if the 0 point is lost? 1. SRVO 062 alarm. This occurs when the pulse encoder information is lost due to untimely battery replacement or other reasons, resulting in the SRVO 062 BZL alarm. 2. SRVO 075 alarm. After clearing the SRVO 062 BZL alarm, the system may display the SRVO 075 pulse encoder position not established alarm. The robot can only move joints individually in the joint coordinate system. 3. SRVO 038 alarm. This occurs during system backup restoration, displaying SRVO 038 SVL2 pulse value mismatch, group I-axis J. At this stage, the robot cannot operate. After knowing the fault phenomenon that will occur when FANUC robot loses 0 point, we will learn the treatment method. First, eliminate the fault. Step 1. Display the 0 point calibration adjustment option. Press the menu key, select 0 next page, then choose 6 system. Press F1, type, and select variables from menu. Highlight the $master_NB variable, input 1, and press enter. Press F1 type. Again, select Master Cal from a menu, enter the System Master Cal interface, and choose the type of 0 point calibration to perform. Step 2. Clear the SRVO 062 alarm. Press F3, or yes_PCA, and then F4, yes. Turn off the controller's power and turn it back on. Step 3. Clear the SRVO 075 alarm. Switch the coordinate system to the joint coordinate system using the chord key. Move the alarm joint by at least 20 degrees in job mode, then press reset to clear the SRVO 075 alarm. Step 4. Clear the SRVO 038 alarm. Follow the same steps used to clear the SRVO 062 alarm. In the System Variable menu, highlight the $DMR_GRP position. Access the Detail menu via F2, Detail. Locate the DMR_GRP_T entry for the relevant group. Press F2, Detail, again to show the next level menu. Change the $master_done variable from false to true using F4, Valid. Access the System 0 point calibration adjustment. Highlight Update 0 point calibration results. Press F4, Yes, to confirm, and press F5, Done, to complete the process. At this point, the 0 point calibration adjustment menu will be hidden. Once all 0 point loss alarms have been resolved, it is often necessary to reperform 0 point calibration. Common methods. Method 1. Full axis 0 point calibration. After clearing the SRVO 075 alarm, full axis 0 point calibration must be performed. Full axis 0 degree position calibration involves assigning 0 markers to each robot axis, then moving the robot to all 0 degree positions for calibration. Since the full axis 0 point calibration relies on visual alignment of the axis, its accuracy is limited. First, teach each axis of the robot to the 0 degree position, aligning the scale markers on each axis. Access the System 0 point calibration adjustment menu and move the cursor to full axis 0 point calibration. When the prompt "Execute 0-point calibration, No" appears on the teaching pendant, press F4, Yes. Select 7 Update 0-point calibration results, Calibrate, and press F4, Yes. After completing the position adjustments, press F5, Done. Restore the actuator control to its original settings and power cycle the robot. Method 2. Simple 0-point calibration. First, set the simple 0-point calibration reference when a robot is in normal operation. The method is: access the System 0-point calibration adjustment menu, move the cursor to set simple 0-point calibration reference, and press F4, Yes. The simple 0-point calibration reference will be stored. Next, perform the simple 0-point calibration. After clearing the SRVO 038 alarm, move the robot in the joint coordinate system to the simple 0-point calibration reference point. Access the System 0-point calibration adjustment, move the cursor to simple 0-point calibration, and press F4, Yes. The robot will complete the simple 0-point calibration. Select 7 Update 0-point calibration results, Calibrate, press F4, Yes, and press F5, Done. Restore the actuator control to its original settings and power cycle the robot. Method 3. Single-axis 0-point calibration. Access the System 0-point calibration adjustment. Move the cursor to single-axis 0-point calibration and press Enter to enter the single-axis 0-point calibration menu. Change the SEL option of the alarm axis, the axis that needs 0-point calibration, to 1. Teach the robot's alarm axis to 0 degrees, that is, align the axis scale markers to the 0 position, and enter the 0-point value, for example 0 degrees, in the alarm axis 0-point calibration position. Press F5 to execute. The corresponding SEL option will change from 1 to 0, and the ST option will change from 0 to 2. We are nearing the end of steps of handling 0-point loss of robot lesson. Remember, don't panic when 0-point loss occurs. Just follow the steps one by one, and all the problems will be solved. Thank you for watching, and see you in the next class.